Today's topic is gas key staking or carrier key staking. This is the method of pushing material here on the carrier key or gas key to prevent the carrier key screws or bolts from backing out. So what we have today is a nickel boron bolt carrier group that has failed my gas key gauge. Essentially there's two settings on this. One is the go side here on the green, and one is the no-go side, which is the red. What I want to see when I'm gauging out bolts is it has to take the green side, and the red side should not go in. And on this one it does. And what that means is this side tells me that it at least has sufficient diameter for the gas tube to go into the carrier without collapsing or wearing the flared portion of the gas tube. If the no-go side goes in, that tells me that the bore of this is oversized. That in itself doesn't mean that the bolt carrier won't function properly. It's more of a sum of all parts thing. So if this is slightly oversized and the diameter of the seal for the bolt tail is slightly oversized, that interfaces with here, and then there's a secondary stage here in the middle that seals the gas rings, and then a third stage which makes contact with this support ring on the bolt. That's probably the least important of the three diameters inside of the carrier, but if you have a loose speck here, a loose speck here, and a loose speck there on the inside, it can run into some gas efficiency issues. This particular bolt carrier group does have a 3-bore is what I like to refer to it. It's too large here, too large here, and too large here. And then if you add in the fact that this is a little bit oversized, it's basically the perfect storm of tolerance issues. So that being said, the main thing that we're going to discuss in this video is replacing the carrier key. And I use a M-Guns Moax tool, and that comes with these staking bolts. And they have a tip on them that is pointed, and it does a good job of staking. The staking that they perform is very similar to what we have here. You can see how it almost fits in there perfectly. Maybe they even use the same tool to stake this particular carrier key. And there's nothing wrong with these. I had a student challenge me to do a little bit more aesthetically pleasing staking, and he wanted more of a sort of a golf ball indent for the staking. There's a company called Psionics that does that kind of staking, really clean looking staking. So it's not something that I've invented, basically just sort of trying to emulate what they're doing quality wise. So what we're going to do is we're going to remove this carrier key. We're going to put a new one on here. This new one I've already gauged out. So takes the green side good, red side does not go in. So this meets my minimum gauging. It's possible that this surface here isn't true, so we're going to check that out too. But I just wanted to show the comparison before we start of the staking bolt. So here's the M-Guns staking bolt, and then here's the one that I made. Now they do function differently. The M-Guns, when you tighten them all the way down until they stop here on the tool. With the bolts that I made, they don't have a shoulder to stop on before the rounded tip starts the staking. So what I use is an inch-pound torque wrench, and I torque it to the same exact torque spec, which is 58 inch-pounds, using this until it stops and breaks. But I'll explain. So what we're going to do first is remove these carrier key screws, make sure that fits. And they weren't that tight. What we run into sometimes, depending on how the nickel boron is applied, you get some corrosion underneath of the carrier key. On this particular one we don't have it, but if you look closely you can see that it's leaking. So we have a little bit of oil underneath here, which is normal on a bolt carrier that's lubricated generously. But if it had a good seal, you wouldn't have all this black soot carbon buildup here. So we definitely have a problem with the interface in itself. So either these gas key bolts screws weren't holding this down hard enough, or this surface here and here wasn't level completely, and it allowed a little bit of space for gas to leak. So what we're going to do is we're going to put this aside. We're not going to reuse that. And we're going to clean this surface here, and then we're going to mount our new carrier key. Use a little bit of acetone. Okay. Now the first thing that I'd like to do is make sure that this surface is true. What I do is I have a whetstone, and I replace these pretty frequently because what I don't want is this to get wavy from using it. So I probably get about 30 uses out of this for the purpose that I'm using it for before I retire them. So what I want to do is see if this surface is level or true. So a little bit of oil in there, a little bit of oil in there. And what I do is just moderate pressure, side to side. And I'm going to look and see how even it is. And this one looks pretty good. I can see that we've removed material almost all the way across the surface. Now this particular area right here, so we're going to hit it a little bit more because what we don't want is gas to be flowing through here and then leak out of this side. So we don't want to take too much material off, because then we're going to lower the deck surface, and this will sit a little lower than the gas key, and they won't interact right without some adjustment of the gas tube. It's a little better. I can still see this low spot here, so I'm going to hit it a couple more times. And I try to change direction so we don't create a surface that's not smooth and flat across. And that looks pretty good. So we have a little bit of a low spot here. That's from the tooling just cut a little bit low right there. Not a big deal because this is where the gas seal is occurring. So we're good there. We'll set this aside. Clean the stone off. Now what I want to do is degrease again. So a little bit of acetone. You could use gun scrubber or brake cleaner. I want to make sure this is clean just right. And make sure when you're grabbing bolt carrier that you don't grab it too hard and collapse anything. Now what we're going to do is, the military manuals will call for a Permatex gasket sealer. This is, it's hard to see it, but it is Loctite 620. This is technically a sleeve retainer. It works fairly good for this purpose, since I use it for barrel bedding. One product working for both is a little more simplistic for me. When this stuff hardens, it's almost like glass. So So I just put a little bit on here. And basically what I'm doing is I'm just creating a small gasket. We've already trued this surface, so the likelihood of this needing any kind of gasket material is pretty slim. But we can't true this surface because this sits down, and the carrier key sits down into the bolt carrier, so we can't get anything here to perfectly true this. So basically the sealant is used for any deficiencies that might be in that surface. Sit it down in here. Now if you wanted to, you could use something like Loctite on these carrier key screws. I don't do that. All I do with these is I slightly lubricate them. If you do use some kind of thread locker on here, it's just going to make them more difficult to remove if you ever have a breakage issue. Some people will use Rockset, some people will use Loctite, but whatever you use, you need to make sure that there's something on there and this isn't bone dry and the bores aren't bone dry, because when you're trying to torque, the value for torquing these at 58 inch-pounds is a lubricated fastener. So if you have a fastener that's completely dry, it can give you a false torque reading. So we're going to make sure that these are lubricated right. Make sure we have the right bit, and of course we don't. There we go. Now we have them lubricated. Now these particular screws are made by N-Guns. These are called Ox optimized carrier key screws. Fantastic. These little teeth here provide some more surface area for the staking to bite into. Absolutely love them. I'm getting a little bit of resistance on these, even as I'm tightening them down. Make sure everything is snug. I'm going to walk this back a little bit. And what I did here is I slipped with the tool a little bit, so I'm going to take that one out. It wouldn't have caused a failure, but it looks bad. But what I'm doing here is I'm seasoning threads a little bit. So since this is a nickel boron carrier, sometimes the nickel boron will get into the thread channel. So I want to make sure that the threads are mating properly between the screws and the carrier, and not giving me a bunch of resistance. And it can't convey in the camera footage, but I'm getting a little bit of resistance here even before I get down to them being snugged. So I'm just working in the threads here. You don't want to go gorilla strength on this. I'm basically just working the threads in. Once I have those where I want them, I'll take my torque wrench. This is an inch-pound torque wrench. This particular one is made by Wheeler. Gonna go right at about 57, 58. Put this in. Make sure it's snug. And there we go. One's tightened. Other's tightened. Gonna go back to this one again. And just ensuring that it is snug. All right. You can see the teeth. So I'm happy with this thus far. Next thing we're going to do is take our bolt carrier out, and we're going to wipe down any of the Loctite that may have oozed out. Now you can use other materials, the Permatex that's called out and the military manuals. It does work. The problem is that it doesn't harden fully. So if you have a carrier key that isn't perfectly true, or a carrier that has a surface that's a little untrue or wavy, the material can blow out. Where this Loctite hardens, so if there is any further inconsistencies on the carrier, which I couldn't correct, it won't blow out. It'll give it a good gas seal. So once I've wiped all that down, what I'll do then is take a piece of weed eater line, anywhere between 0.060 and 0.080, and I'll run this in. And if any of the Loctite got in to the bore, and it looks like a little bit did, this will get it out. We don't want any of that stuff oozing anywhere. I got that out. I'll take a swab and run it inside where the carrier key screws are, just in case something got in there. Now we're ready for staking. So we're not going to use the M guns, and if you notice, I only have two here, and the reason that I have two is because I do them on each side and then I switch over. So the first thing we'll do is, and this is modifications that I've made, I made it front, rear, and I put an arrow on it there in the middle. And the reason that I do that is because there's a slight difference in the shoulder portion from here to here than from here to here. So if I were to use this tool and then flip it for whatever reason when I'm working on it, it can cause the staking to be maybe here on this side and a little bit further forward on the other side. So I just try to keep everything consistent. So what we'll do, and this is something that you don't have to deal with the factory M guns, is they're pointed and they tend to stay sharp. They don't roll over or gall or burr easily. You don't have to use lubricant. So the method that I use is a little more involved. So the bolts are rounded on the tip, and with use sometimes they gall, scratch, chip material off. So when that happens, between every use, I go over to a buffing wheel, and this is 240 grit and 550. So if the tip gets damaged, I'll hit it with the wheel to take any of the burrs off, and then I'll hit it with the polishing wheel just to make sure that it's smooth. So once we have that done, what we're going to do is position our MOAX, and then what these tools do is they interface with the carrier key screws and lock this in place. And as you can see, there's a little bit of wiggle. So this one doesn't fit. This is a different size. They have 2 different sizes for 2 different carrier keys. I still use it. So as you can see, there's wiggle both ways. So what I do is I make sure it's in the middle when I do my staking. So a little bit of synthetic grease, put it on the tips of my staking bolts. And if you don't make sure that these are nice and smooth and nice and round, they will not do a good job when it comes to staking. So I'll tighten these down. Finger snug. You can still see that they're nowhere near shouldering out. And like I said, we have a little bit of play. So what I do is get it right there and I snug it. Still have this set to 58 inch-pounds. I'll tighten one slightly and then the other slightly. Alright, that's it. I'll loosen these. I apologize for the camera shaking around like crazy. It is mounted to a helmet. The reason that I'm getting lubricant on the threads too is I want to prevent the threads from binding or getting worn out on the jig itself. So using lubricant just helps cut down on some wear and tear. You absolutely do need to put lubricant on the tips for staking though. So again, I'll snug these. Right about there. Take these out. And there's our golf ball staking. That's it. Now if a little bit of discoloration that occurs here where it gets silver bothers you, then you can just take some Brownell's Oxo Blue, put it on a swab and rub it on there, and those silver areas will disappear. But this bolt carrier is now repaired. If you have any questions, go ahead and throw them in the comment section. Thanks for watching.